And we have, okay, here we go. All right, so we're just going to finish up with these last few problems from section 9. So we want to solve the inequality. And so just like yesterday, we've got this rational function. And so we said we want to set the numerator equal to 0, and we want to set the denominator equal to 0. So maybe while we're here, we just write that down again. We're going to set the numerator equal to 0 to find the zeros. We're going to set the denominator equal to 0 to find vertical asymptotes or any other breaks in the graph. And those answers to those two questions, we're going to put on the number line, or what we would call our sign chart. Right? That's all from yesterday. All right, so what I'm going to do in order to easily do this is I'm going to make sure everything's factored. So let's factor the numerator. That's a difference of squares. The bottom is already factored, right? X plus 1 times x plus 1, which, you know, x plus 1 squared. Still, I'm going to leave it that way. But why I like to do it like this is for two reasons. One, then it's very easy to set the numerator equal to 0 because, well, because we see it, right? So these are my zeros, or x-intercepts. And then we're going to set the denominator equal to 0, which is x equals -1, and that's my vertical asymptote. Let's go get that on a number line. So in numeric order, I've got -3, then I've got -1, then I've got +3. Again, this is just a nice little, like, you know, what did we do yesterday, kind of warming us up here. I'm going to mark on my sign chart this information here. So at -3 and +3, I had x-intercepts. But at -1, I have that vertical asymptote. This, why I like to do this, I know I said this yesterday, is so that I don't have to keep looking back up here. Everything now that I need will be on my sign chart, okay? Well, let's go fill in the signs to our sign chart. Now, just like we did, I'm glad, I think Katie asked about number 3 on the homework. Just like on number 3 on the homework, when I see something squared, that means no matter what I plug in for x, this whole expression will be positive. So when I go to make my sign chart, the denominator will always be positive. I think that saves us a heck of a lot of time. Please don't forget to look at that. Anytime you have something squared, something to the 4th, something to the 6th, make sure you're addressing that. All right, so let's go to the top now. I'm going to plug in something like a -4. Again, -4 plus 3 is a -1. -4 minus 3 is a -7. I don't care that they're 1s and 7s. I care that they're negative. So I've got a negative times a negative divided by a positive. So that interval is positive. And then we just keep on going. I'm going to pick a -2. Notice again, I'm going to say it, I'm not marking anything else on my sign chart. If it helps, you can come maybe right down here, like plug in a -2. But I'm trying to not clutter this that much. So when I plug in a -2, -2 plus 3 is a +1. -2 minus 3 is a negative. And so overall, a positive times a negative is negative, divided by a positive is still negative. All right, let's go to the other side. Let's go plug in a, I don't know, a 0. 0 is a nice number between -1 and 3. If I plug in a 0, I get a positive times a negative, and I'm dividing that by a positive. And then I keep going, and I plug in something like a 4, and I get a positive times a positive, divided by a positive. Awesome, so nothing in here is different from what we did yesterday. Just a nice little chance to warm up. All right, so we're ready to answer the question. And the question from the very beginning is, when is this graph less than or equal to. So below or negative or on the x-axis. So below or on the x-axis, which just means I get to include my zeros. So below would be here and here. Let's write that in interval notation. So I'm going from -3 to -1. I'm going to include the 0 because it said or equal to. I cannot ever include a vertical asymptote. And then we'll go again from -1 to 3. I get to include the 3 because it said or equal to. Okay. How's that look, folks? Questions, comments? All right. Well, let's go to the next one. Now, the next one's a little bit different. I mean, it looks a little bit easier, right? Less going on. However, and this is not a typo, it says 10 to the x. This is different. This is a different kind of function altogether. However, we're still going to treat it the same way, right? I still want to set the numerator equal to 0 to find the zeros. I still want to set the denominator equal to 0 to find any breaks in the graph or vertical asymptotes. Again, I just wrote the same thing down. You don't have to. So we said on the last one, well, let's factor, factor, factor. So maybe that would have been step 0. Factor first so that we can easily look and see those things. Well, guess what? The numerator is an exponential function. There's nothing to factor. But I'm still going to set it equal to 0. So 10 to the x equals 0. That's me setting the numerator equal to 0. And then the bottom, and we'll come back to that, the bottom is a quadratic. Awesome. But it doesn't factor. It's not a difference of squares. There's no GCF. So I think the best thing I can do is just write x squared plus 5 equals 0. And let's solve both of these things. In fact, let's look at the one that's probably more comfortable at this point. If I move the 5 to the other side and then I take the square root, I get imaginary numbers. And when we're talking about a graph, we don't graph imaginary answers. So if we're talking about finding problems, there are no problems, right? So I don't have any vertical asymptotes or breaks in the graph. Well, maybe that's good news. Let's go to the other side. 10 to the x equals 0. You know what? I'm going to look at the graph of this. Let's graph the exponential function 10 to the x. 10 to the 0 is 1. 10 to the first is 10. Remember, all exponential functions look like this. All exponential functions have a horizontal asymptote on the x-axis. They pass through the point 0, 1, and then they just kind of shoot up forever. Does this exponential graph ever equal 0? No. So there's also no zeros of the numerator. So the denominator never equals 0. The numerator never equals 0. Well, wait a second. Then what do we have to put on our sign chart? Nothing. So with these two things together, there are no, let's call them critical points or critical numbers to put on our sign chart. Yikes. Well, all that means is that this graph is not going to change signs. That's what that means. You can still use a sign chart if you want. You just don't have any changes happening. You can still pick a number. I don't know. The easiest number to plug in is 0. If I plug in a 0, 10 to the 0 is 1. That's a positive number. And if I plug in a 0 down here, 0 squared is 0 plus 5. A positive divided by a positive overall is a positive. If I don't have any critical numbers to put on my sign chart, that just means my graph is not changing signs, which means it's either always positive or always negative. And by plugging in a 0, so we just plugged in, I plugged in x equals 0. I picked my favorite, easiest number. We see it's positive. Well, what did they ask? From the very beginning, they said, when is this graph less than 0? Below the x-axis or negative? It's never negative. This graph is never below the x-axis. And you know what I think we should do, because this is a little more uncomfortable? Let's go ahead and look at it on a graphing calculator. I'm going to pull out an 84. You pull out whatever you have, even if it's Desmos. So I'm going to go to my y equals. I'm going to type in, I'm going to type in 10 to the x on top and x squared plus 5 on bottom. And I'm going to hit graph. Now, based on our sign chart, we believe this graph is always above the x-axis. No, I certainly don't see anything down here. Now, just because we don't see anything doesn't mean that's it. We should maybe play with the window a little bit. But at least within this negative 10 to 10 window, I feel pretty good with my answer. Because at first, maybe some of you were going, wait, there's nothing on that sign chart? Maybe that was uncomfortable, right? But it's okay. Because if this graph is never negative, then you're right. We shouldn't have had anything. Now, I don't see what's going on over here. But anyway, so we could remove the axes just to see what's going on. Or if you have a calculator that graphs in color, maybe you see what's going on a little bit better. But the key for me is that there is nothing below the x-axis. How's that look for us? A little bit different, isn't it? So I didn't actually ask the calculator to like find anything. I just wanted to view the graph, right? So I just kind of added that note. Let's just look at the graph. We didn't find anything. We just looked at it, okay? All right, let's take a look at this last one, which we are going to use a calculator to do this entire thing. So it says use a graphing calculator, or again, some of you at home are going to be using Desmos, and that's okay, to solve the inequality. If we have a calculator, we should be doing very little by hand, if anything, right? So let's think about what they're asking us to do. We're doing the same thing, just we're going to find the answer differently. So they want to know, when is this graph, right, less than 0? We've been saying this all along. Less than 0 means below the x-axis. Or, again, we've been using the phrase negative also. When is the graph negative? When is it below the x-axis? Well, gosh, I think the best thing we could do is to go get a graph. So I'm going to use an 84 at first. And if you're using something different at home, that's of course okay. Ask questions, okay? So let's go graph this function. Everyone, if you're using Desmos, go to desmos.com, type this function in. Using Inspire, start a new document, get a graph page, type this function in. I've got a fraction. I'm going to graph x cubed, get out of your exponent, plus x squared, get out of the exponent, minus 5x, all over 2x minus 3. Do yourself a favor when you're using a calculator and you're typing in a function. Just go back and look at it before you hit graph. Make sure it matches. You hear me a lot of times saying, get out of the exponent. Because some of us get so wrapped up, I'm actually going to show you what I mean. Some of us get so wrapped up in typing this in that we do something like x cubed plus x squared minus 5x, and all of a sudden the rest of our function is stuck up there in our exponent. So just quickly glance up and make sure that that's exactly what you wanted to type in. All right, so sorry about that. I just felt like it was worth talking about. Making sure that those 3 terms are all on the ground. Okay, let's go hit graph. Now, for some of you, depending on what you last used your calculator for, you may want to change your window. I would probably always hit zoom and then go down to number 6, which is standard to start. So when I graph, I typically type in my function, then I hit zoom 6, because that's going to set me up to go from -10 to 10 and -10 to 10. And then from there, you can change whatever you want, okay? You know what I think would be helpful for us is if we go ahead and just lightly sketch this on our paper, just so we have a lot of good things to talk about. So I'm going to just, with my pencil here, I'm going to just take what I see. It doesn't have to be fancy. I'm just going to take what I see on the calculator. Oh, geez, I know this light, it keeps getting in the way. And just translate that onto paper. So it looks like we've got a graph that comes down like this. It looks kind of like it crosses at 0. I'm not going to assume it crosses at 0. It looks like it gets pretty steep here. And then it looks like it comes down like this. Okay. I'm just moving my calculator out of the way for just a moment. The reason I did this is I just wanted us to be able to look at this graph and talk about what we want to go look for. All right, so let's see. I want to know when the graph is below the x-axis. Below. So I'm just going to go in with some sort of color here and just kind of note to myself, when is this graph below the x-axis? Okay. Well, so I see 2 intervals. I think you also see 2 intervals, right? We're going from here to here, and then from somewhere in here to here. Let's talk about that for a minute. So, whoops, this we know is important, this we know is important, and this we know is important. The question is, look at this break in the graph. It's a vertical asymptote. We have to know that. The calculator won't show a vertical asymptote, will it? So we have to see that. We also have to know where it is, because there's no way to ask the graphing calculator where the vertical asymptote is. So remember, straight up here, vertical asymptotes come from zeros of the denominator. So very quickly, if I set my denominator equal to 0, I get 3/2, which is 1.5. If you can read my handwriting, get that decimal point in there. So while we're going to use the calculator for almost everything, we do have to use our brains a little bit here to know where that vertical asymptote is. So we need the zeros. This is nothing different than what we did up here. We need to find the zeros, and we need to find the vertical asymptotes. This time we're just using the calculator to find the zeros. But we did that the other day. We already talked about how to find zeros on a calculator. So I need to go find this one, and this one. All right, let's go do it. If you feel like you need to zoom in, then go ahead and zoom in. I'm sorry, this is, okay. So I'll switch sides here. There we go. All right, so let's go find this 0 first. So I'm going to hit second trace, go down to 0. If I'm trying to find this one first, we can type in numbers. We talked about that. It looks like it's negative. Looks like it's around -3, so I might go from like -5 to -2, something like that. Or you can start on the left side of the 0 and hit enter, and then go to the right side of the 0 and hit enter, and then hit enter again. And I was expecting this. If I'm giving you a calculator to do something, you're going to probably assume that those numbers are not going to be so nice. So we're going to the nearest thousandth, -2.791. I'm just going to write it down. -2.791. Remember, if you're using an Inspire, you're hitting menu, number 6, number 1. It's the same questions though, left bound, right bound. Okay, let's go find the other 0. Second trace, 0. It actually looks like it's at 0. Maybe I'll just say, let's look from -1 to +1. And I don't want to guess. Oh, look at that. That is a nice one, isn't it? Okay, so that's good. So that is exactly at 0. I like that. And you know what? Doesn't surprise me, because if you factor out that GCF, yeah, there it is. Okay, let's go find that last one. Second trace, number 2. Now, this is the tricky part, is that we need to get over that asymptote, right? So you can arrow up, and it does get over there. Okay, perfect. So I'm on the left side of that 0, hit enter. Arrow to the right a couple times to get on the other side. And it looks like 1.791. Now remember, on Desmos, it will spit out all of those zeros for you once you graph the function. So we're just going to make sure we write all those down. Okay. So remember, I'm going to mark a little note here. This asymptote is at, we already said 1.5. All right, so we're ready to write our answer. When are we below the x-axis? From negative 2.791 to 0, right? From here to here. And then we start just to the right of 1.5, so we just don't include it. And then we're going to stop at 1.791. And because it did not say or equal to, I'm not using any brackets in there. Woo! All right. So I'm going to go ahead and stop the recording.